Okay, so far, in the previous videos, we went through the first 6 steps of the 8-step process of being able to do a hypothesis test. So we identify the population parameter of interest, state the null and alternative hypothesis, identify your level of significance, check your requirements for normality. Now, E, draw the sketch. Again, you don't have to do that. If it helps you to understand better, then you can. Otherwise, you can skip that step. We just showed you how to calculate the value of a test statistic, T. Now what we're going to do is be able to tell you what a p-value is and how to find it, and then compare it to alpha so we know how extreme our sample data is. Okay? So we might as well head on and do that. All right. What a p-value is short for a probability value. It's the probability of getting a value of the test statistic, that t-value that you just calculated, that is at least as extreme as the one representing the sample data, assuming that the null hypothesis is true. And again, that's under the assumption that the null hypothesis is true. If you get a very, very small probability value, basically what that's telling you is that your data is very extreme and varies greatly from what we assume the null hypothesis to be. In other words, if the p-value is extremely small and less than what we assigned alpha to be, then we reject the null. Okay, our data is strong enough to say that the null is probably not true. Or it's strong enough to say that the alternative, there's evidence to say that the alternative could be true. Okay, if the p-value is larger than alpha, then the evidence isn't strong enough. Our data, our sample data, could be just differing from the null because of chance variations in the sampling process. So the p-value, if it's greater than or equal to alpha, we fail to reject the null. Now, how do we calculate or find that p-value? Well, we're going to end up going to, once you calculate your test statistic, we're going to go to our t-distribution. And I just kind of made this one up here, but when you calculate this, for 26 degrees of freedom, that's what you're going to type in, ladies and gentlemen. Whatever your degrees of freedom is, you're going to type it right there. Now, the type of tail, upper tail, we're either going to use upper tail, lower tail, or a central value here. But this is determined by your test statistic value. If your test statistic is positive, you're going to use an upper tail, greater than. If it's negative, you're going to go lower tail, okay? And then, ladies and gentlemen, we'll specify this right here is T, what we just calculated. That's your test statistic. And this will probably make more sense when we do an example. Now, for instance, I went ahead and typed this in. Ladies and gentlemen, you'll see that right here, in other words, a p-value measures the probability that you will get another sample that is more extreme than yours. This right here is your p-value written as a percent. Now again, we don't want to do that. We want our p-values to be written as a value between 0 and 1. So the actual p-value here, if you write that as a value between 0 and 1, is you change that over to a decimal, 0.028. Okay? Now, this right here, ladies and gentlemen, represents all the test statistic values that are more extreme than what you found for your data. So in other words, basically what we're saying here, ladies and gentlemen, this is read as 28 thousandths, or I would just say it's pretty close to 0.03. So what we're basically saying is if we took samples from the entire population, that roughly about 3 out of every 100 would be more extreme, ladies and gentlemen, than our sample. Now that's not a very good likelihood that you'll get sample data that's more extreme than yours. So in other words, what that's basically saying, ladies and gentlemen, is this, that our sample seems to be pretty extreme. Now, how do you know that value, this p-value here, is going to disprove, or, if it's going to help you to reject or fail to reject your null hypothesis? Is it strong enough to say that the null might not be true? Well, again, what we do is we compare this value right here to whatever alpha was. okay? If this is smaller than alpha, ladies and gentlemen, then you know what? Then we reject the null. If it's larger than alpha, then yes, we're varying by about 2 standard errors from what the null is, what we're hypothesizing the null to be, but that's not strong enough to say that that disproves what the null is, okay, what we hypothesize it to be. So let me just go through this one more time here, just make a quick sketch. Let's say, for instance, we got the null hypothesis. Now, I'm going to just make this up, okay, is 100, or that's what it's hypothesized to be. We're testing it to be 100. Is it 100? The alternative, ladies and gentlemen, would be that the null is greater than 100. Now, again, I'm just making this stuff up, all right, for your sake. Alpha, we're going to predetermine to be 0.05, all right? So if we draw a picture here, ladies and gentlemen, okay, and here is where alpha is at, right here. So in other words, remember what alpha means? Alpha is the probability that we would accidentally reject a true null hypothesis. So what I'm basically saying is like this. Let's say, for instance, now this is why we're testing, but let's say that this is true for the population. Now we don't know that, we're testing, but let's just say it is true. Then what we're going to say by alpha is that about 5 out of every 100 samples will be strong enough to reject the null when this is true. So if you have sample data that lies out here, the test statistic lies out in this alpha region, what we're saying about 5% of the time, we're going to allow, and it's not very big, but if the null is true, we would be rejecting the null hypothesis, saying it's actually true. Okay, that happens sometimes. Now, how do you lessen that? You never eliminate it, but how do you lessen it? Make your alpha closer to 0, like 0.01. Then only 1 out of every 100 samples approximately you'd be rejecting a null hypothesis that is true. We're going to stick with that. Now, let's say we come up with our sample data. And let's just say our sample data, ladies and gentlemen, gives us a p-value. Again, I'm making this up. That's equal to let's make this pretty simple, 0.02, let's say. So what we're saying is that only 2 out of every 100 samples from this population would be more extreme, would come up with a test statistic t that's more extreme than ours. Well, again, alpha is 5 out of every 100. This is a smaller area. Remember, this is 5% of the area under the curve. This is only 2% of the area under the curve. So where's that located? It's got to be located out here. So right here, ladies and gentlemen, this is your p-value that we found from our test statistic. And again, I made these up. It'll make more sense when we do examples. But basically, that p-value is saying only 2 out of every 100 examples are going to be more extreme than what we came up with. Alpha says we're allowing 5 out of every 100 samples to approximately reject a true null hypothesis. So you see, because our p-value is less than alpha, in other words, our p-value, our test statistic, is lying somewhere out here in this region. This was, by the way, for a t equal to some value. That, ladies and gentlemen, we're going to reject the null. In other words, our test data was strong enough to put us way out here in this tail, past alpha, that the data from our test statistic is strong enough to say that, you know what, the null is probably not true. Okay? So we have enough evidence then to say that the alternative is probably true. Now, if your p-value is larger than alpha and it lies in this non-red region, your non-alpha region, then basically what that's saying is, yeah, you may be higher than the hypothesized null hypothesis, but that variation could be just due to chance fluctuations in the sample, your sampling process, and so forth. It's not necessarily strong enough to say that we are going to reject the null and say the alternative is true. Okay? So if you understand that, if you don't, give me a call, I know this video went over a little bit, but I think it's important that you know what a p-value is and how we compare it to alpha. So if you have questions, let me know, please. Give me a call, give me an email, and we'll get back to you, and I'll try to explain it in a different way or better if I can. But now, if you understand that, then really the last step is just to state your conclusion, which we'll do in the next meeting.